Because objects of subclass types may be used freely wherever a superclass type is required, there may be some times that an issue arises where we need to know exactly what it is that we were passed. So for example, a circle is a geometric object, but if we have a piece of code where you use, say, a geometric object and it's passed in as something called my object, but it could be a circle or it could be a rectangle or it could be a triangle, you might need to know what it actually was. In other words, even though its declared type was object, you might need, or geometric objects, let's say, you might need to know specifically, okay, it's a geometric object, but is it a circle, a rectangle, or a triangle? And in this case, we have a special keyword instance of that allows us to determine that. So when we say if my object instance of circle, what this is doing is the instance of acts as an operator which produces a Boolean result based on a comparison of the objects on either side of it. And it's asking, is the object on the right hand side a descendant of the object on the left hand side, or I guess I should say the class. So in other words, in this case, when we say my object instance of circle, we're asking, is the object we were passed a circle or a triangle or something else? And if it is a circle, this will return true, otherwise it returns false. And the reason we might want to check this is based on what you saw on the previous slide. You can't arbitrarily cast anything as anything. If you're going to try to cast my object as a circle, then you better make sure that it is actually a circle. And this if statement will give you the capability of determining that. So if the if statement passes true, then you know that my object is a circle. And because you know it's a circle, it's perfectly acceptable for you to cast it as a circle. The reason you would have to cast it as a circle is because the get diameter on the last line of this example is a method that only exists in the circle class. It's certainly not in the geometric object class, and of course it's not in the rectangle class or the triangle class, because none of those figures, and figures in general, don't always have diameters. But a circle does have a diameter. So we can't use the diameter method apart from using it with the circle class, and that means we need to make my object look like a circle before we can use it. There's actually a little trick that arises in the previous slide, and this slide brings it up as a caution to be wary about. And that's that there were a pair of parentheses that you may have thought looked redundant in the previous slide. They're shown in red at the bottom of this slide. Those parentheses are necessary, and the reason for that is that the dot operator has a higher precedence in terms of order of operations than the cast operator. So if you don't have those red brackets in there, what will happen is we will attempt to take the dot get area method of my object and then cast that result as a circle, which of course is nothing close to what we want to do here, because the get area method returns a double, and you're not going to cast a double as a circle. And besides that, the get area method is not a method of my object, because in this particular instance my object would be a geometric object which does not have a get area method. So for this to make sense at all, we need to first of all cast my object as a circle, and then take the result of doing that, which is now a circle object, and use it in conjunction with the get area method. To enforce that order of evaluation here, we need to put those red brackets in, or it simply won't work correctly. We have a demo that we're going to look at in the Eclipse IDE now that demonstrates polymorphism and classing. What the example does is it actually creates two different geometric objects, a circle and a rectangle, and then invokes the display object method to display those objects. The display object method is going to show the area and diameter if the object is a circle, but instead it will show just the area if the object is a rectangle, since obviously a rectangle does not have a diameter. So this is a case when we need to know at runtime which display method is going to be appropriate for the type of object that we were passed.